Hello, my name is Mr. Fontenot, and I'd like to welcome you to my YouTube page, Mr. Fontenot 1111. Please like and share the page. It will help me out with the algorithm that YouTube uses to send me more viewers. For updates when I upload new videos, please subscribe to my channel. Please leave a comment if you enjoy this video or you have anything you'd like to share with me. In the video's description below, you will find links to my other videos and links to printable versions of the formula sheets that I will be using in this video. And that will be in the description below the video. In this video, I'm going to be going over Span Math homework number 4. And before I go over this, I'd like to tell you why you need to know how to do span math. So span math is one of the most commonly used maths in industrial instrumentation. You need to understand span math to understand the concepts of how instruments interact with one another. Of course, you need to know how to do span math because span math will be on all of my tests. But you really need to know how to do span math because once you try to get a job with a plant, with local industry here, they're going to give you what's called a craft test. And in that craft test, they're going to ask you several things, and they're going to want to see if you can do several types of math and other things, and one of those things is span math. So in order to be prepared for that exam, you need to know how to do span math. The equipment I'll be using and handouts I'll be using in this video, I'm going to use the Casio FX115ES Plus. Now, what I have is the first generation, but you'll probably have the second generation that looks like this. Here's what the second generation looks like. It's a little bit more square, and it's white. But it's the same calculator virtually. They both do the same thing. So what you'll see me broadcasting in my video is the first generation. Software that I'm using to record my desktop is called Camtasia Desktop Recorder. And the learning management system that we're using to do all of our assignments is the Canvas LMS. Also going to be using in this video the Span Math FHO, which stands for Formula Handout. Okay, let's go over what you see on the screen here. Up here at the top left, you see our Canvas. I already have it open to the Span Math homework number 4 answer sheet assignment. As already mentioned, the calculator and the Span Math formula sheet. Now for my Canvas assignment, I've already submitted it, and you'll see the answers, the correct answers down below. Of course, all of mine are marked wrong because I didn't put anything, but we're going to go back through this and I'm going to show you how to get all of these correct answers here. Okay, with our calculator, there's a couple of things I'd like to go over with the calculator first to make sure that you understand some things about the calculator. So these are multifunction buttons. If you just press the button, you get what's in black on the face of the button. If you hit Shift, you get what is in gold above the button. If you hit Alpha, you get what is in red above the button. And you see that some of them don't have an alpha function. So what I want to do first, after I do this, you may want to pause the video and make sure you have your calculator set up like this. Let me tell you this first. If you ever get your calculator hung up and it won't do right, what you do is you hit Shift, then you hit number 9. You can see above it, it says clear. So you hit number 9. And it's going to ask you if you want to clear your setup, clear your memory, or clear everything. So basically what we want to do is we're going to clear everything. We're going to set it back to factory settings. Are you sure you want to do that? You're going to hit equals. Reset all, press the AC key. So now we're back to factory default settings. So then what we're going to do is we're going to hit Shift, we're going to hit Setup, we're going to hit 1, and then we're going to hit 2. Next, we're going to go Shift, Setup, and we're going to do number 8, which is normal, 2. Okay, so again, that was Shift, Setup, 1, 2, Shift, Setup, 8, 2. Okay, now next let's take a closer look at our formula sheet. If you do not have the formula sheet, there will be a link to print the formula sheet out down below the video, or you might want to just take a piece of paper and just copy everything that you see on the screen here for the formula handout. And I'm giving you some ranges here, and these are the standard ranges that we'll be referring to when I use the verbiage in the question, standard milliamp range, 4 to 20 milliamps, or standard PSI range, 3 to 15 PSI. Also have the 24 volts. This is what your transmitters run on, and the element itself, the sensor, is a 1 to 5 volts DC voltage. Okay, we're given two formulas down below here. The first formula, number 1, is if you are given a percentage. Only when you're given a percentage, you can use formula number 1. Formula number 2 will be if you're looking for a percentage or in all other cases. Don't worry, I'm going to show you exactly when to use each formula. Now here's a formula that's found in the textbook, but it's the same formula just with different letters, but mathematically it's the same formula. And I want to remind you here, when we're using the formula, looking at formula number 2, everything to the right of the multiplication sign is what we're looking for. So anytime the question is phrased in a way, and I'll show you and highlight as we go through the questions, but basically whatever you're looking for goes to the right hand side of the multiplication sign. Just think of this as being a line of demarcation. What you're given goes to the left, what you're looking for goes to the right. I have another video where I'll go into great detail with an overview of the formula sheet and how to use the formula or formulas. You may want to make sure you check that video out. It's under the playlist that I have on my channel for Span Math. There's several videos in that playlist. If you're currently enrolled in my class, this assignment in Canvas is set up to allow multiple attempts. So if you make any mistakes, you can redo the assignment if you would like to get it correct, especially if you accidentally make a small rounding error or something like that. I'm going to ask you to round to 2 decimal places, or the 100th place, basically the second place to the right of the decimal point. And I'll be showing you that as well as we go through the assignment today. Okay, let's take a look at number 1. The question is, with an operating range of negative 250 to 25,000 pounds a second and a measurement of 15,693.32 pounds a second, how many milliamps will be sent to the transmitter from the transmitter to the DCS module? So it says how many milliamps. So we are looking for milliamps. So in this case, we have to use formula number 2. Let's scroll down, look at formula number 2 here. So look at my calculator. I'm going to open parentheses, hit over under. I'm going to punch in this first number right here, 15,693.32 minus 250. So in this case, it's very important that you do minus 250 because it says negative 250. hit your arrow down. You're going to do 25,000 minus again 250. Scroll over, close parentheses, times, open parentheses. Now we've moved to the right-hand side of our multiplication sign. And it said with an operating range of this and a measurement of this, how many milliamps? So this tells us that we're looking for milliamps, and that tells us that that should go to the right of our multiplication sign. So what is our standard milliamp range? Well, it was right here. 4 to 20 milliamps. So what are we going to do next? We're going to say 20 minus 4, close parentheses, plus 4. Our answer is 14.10, or you can put 14.1. There is a margin of error. So it's 14.1 milliamps. These are numerical answers only, so you wouldn't be able to put milliamp in there anyway. You can't put the letters for milliamp in there anyway. I'm not requiring you to, but since it's a numerical answer, it won't let you do it anyway. All right, let's take a look at number 2. How much pressure will be sent to the control valve actuator if the control valve transducer receives an 19.64 milliamp signal? So I'm looking for pressure. How much pressure? So that tells me milliamps is going to go to the left of my multiplication sign. I'm going to start with milliamps. So open parentheses, hit over under. I'm starting with milliamps, so I'm going to do 19.64 minus 4. Scroll down, 20 minus 4, scroll over, close parentheses, multiply, open parentheses. Since I'm looking for pressure, I'm going to punch in my standard pressure range numbers, 3 to 15 psi, so it's 15 minus 3, close parentheses, plus 3, equals 14.73. How much pressure will be sent to the control valve actuator if the transducer receives a 19.64 milliamp signal? Well, if it receives 19.64 milliamps, it would send a pressure of 14.73 psi. Number 3. With a flow rate of 500 to 25,000 gallons per hour, how many gallons per hour would equal 17.79 milliamps to the control room? So we are looking for gallons per hour. How many gallons per hour? So that tells me I have to start with milliamps because I'm looking for a gallons per hour. So I'm going to open parentheses, hit over under. I'm going to punch in 17.79 minus 4 over 20 minus 4. Scroll over, close it, times, open it. We're going to put in what we're looking for. We're looking for gallons per hour, so I'm going to punch in my gallons per hour numbers, which will be 25,000 minus 500, close parentheses, plus 500, and it equals 21,615.9375. Now we're going to round the second number after the decimal place, so the answer would be 21,615.94, using the 7 to round the 3 up to a 4. Right here, 21,615.94. Number 4. With a flow rate range of 500 to 25,000 gallons per hour, how many gallons per hour would equal 18.8 milliamps to the control room? So it says how many gallons per hour. So that's what I'm looking for. So that tells me what's going to go to the left of my decimal of my multiplication sign. And what I'm going to start with is milliamps. So open parentheses, hit over under, 18.8 minus, reminder, the range is 4 to 20, so I'm going to put the 4 in, scroll down, 20 minus 4, scroll over, close parentheses times, open parentheses. Okay, I'm looking for gallons per hour, so it's going to be the 25,000 minus 500, close parentheses, plus 500 equals 23,162.5. So if I had a flow range of 500 to 25,000, and I'm receiving a milliamp signal of 18.8 milliamps, that tells me that I have a flow going through the pipe at that moment, if I'm receiving that many milliamps, of 23,162.5. Number 5, how much pressure, so I'm looking for pressure, will be sent to the control valve actuator if the control valve transducer receives an 11.72 milliamp signal. So I'm going to start with milliamps, open parentheses, hit over under. I'm going to punch this number in first because that's my process variable, 11.72 minus 4 over 20 minus 4, scroll over, close parentheses times open parentheses. I'm looking for a pressure, so it's going to be 15 minus 3, close parentheses, plus 3 equals 8.79 psi. If the transducer receives this much current, it will produce this much pressure. Okay, number 6. How much pressure? Again, looking for pressure. Will be sent to the control valve actuator if the control valve transducer receives an 8.78 milliamp signal. So we're going to start by putting in our milliamps. This number right here, this PV1, that corresponds to the 8.78. So open parentheses, hit over under, 8.78 minus 4, scroll down, 20 minus 4, scroll over, close parentheses times open parentheses. We said that we were looking for pressure, so it's going to be 15 minus 3, close parentheses, plus 3, and that's going to equal 6.585. So we should round up 6.59. Your answer should be 6.59. Now, something must went a little wrong here because the correct answer is showing 6.58. But there is a margin of error of 0.01. So if you put in 6.59, following the rounding rule I gave you, it won't mark it wrong. I don't know why this says 6.58. But there is a margin of error here that there's a little leeway with a mathematical answer, so it should be just fine. All right, number 7. With an operating range of 250 to 25,000 pounds a second and a measurement of 7,537.92 pounds a second, how many milliamps will be sent to the transmitter? Will be sent from the transmitter to the DCS module. So the question is, how many milliamps? So I'm looking for milliamps. Since I'm looking for milliamps, I'm going to start with these pounds per seconds. So I open parentheses, hit over under, I'm going to punch in this number right here, which is my PV1, my process variable 1. So it's going to be 7,537.92 minus, we're going by this range, so it's going to be minus 250 over 25,000 minus 250, scroll over, close parentheses, times open parentheses, milliamps. How many milliamps, it says. So we're going to do 20 minus 4, close parentheses, plus 4 equals 8.71 milliamps. If I had this many pounds per second, I would have 8.71 milliamps coming from the transmitter going to the DCS module. Number 8, how much pressure will be sent? So it's pressure. How much pressure will be sent to the control valve actuator if the control valve transducer receives a 5.6 milliamp signal? So the 5.6 milliamp signal, that's going to be our PV1. So open parentheses, hit over under. We're going to put our 5.6 in there. Minus 4 over 20. Minus 4, scroll over, close parentheses, times open parentheses. And let's see, we were looking for pressure. So it's going to be 15 minus 3, close over, plus 3, because 3 to 15 psi is our standard psi range. It equals, and it's 4.2. How much pressure? If I receive 5.6 milliamps, I'm going to receive about 4.2 psi. Number 9, with a flow rate of 500 to 25,000 gallons per hour, how many milliamps? So we're looking for milliamps. That tells us that's going to go to the right of our multiplication sign. Would be sent to the controller from the DP transmitter at a flow rate of 12,099 gallons per hour. So I know right away my 12,099 is my PV1. So I open parentheses, I hit over under. I'm going to punch in my 12,099 minus my 500. Scroll down. 25,000 minus the 500. Scroll over, close parentheses, times open parentheses, and we said that we're looking for milliamps, so that's going to be 20 minus 4 plus 4. And you get this number here. If you ever get a fraction, you just hit the S to D button and it gives you your decimal answer. And our answer is 11.57. Number 10. 35% of the standard milliamp range would equal how many milliamps? So in this case, we can use formula number 1. The 35%, we're going to convert that to a decimal, so that would be 0.35. Times open parentheses of what we're looking for, 30% of milliamps, so we're looking for milliamps, so it's 20 minus 4, close parentheses, plus 4 equals 9.6. 35% of the standard milliamp range would equal what? 9.6 milliamps.